and I'm a physicist. I tell people that, and they tend to kind of freak out. People say, well, physics is scary, or physics was hard, or I hated my physics class. And I think that's sad. I think physics is a lot of fun. And I'm going to give you 5 reasons today why you shouldn't be scared of physics, but instead you should try it out. Physics describes the real world. Sometimes we lose sight of that when we're working on a hard problem or a difficult homework, and we feel like this is just kind of pointless. But actually, every single thing we learn in physics tells us something about what happens in the real world. And while at first we might start with problems like blocks on a ramp that don't feel very real, it turns out we actually can use those same basic techniques to describe things that are very real and very cool, things like stars or cars, any number of things happening out in our world. Remember when you were in your Algebra 2 class and you said to the teacher, "When am I ever going to need to know this?" Well, it turns out physics is one of those times where you need to know this. It's one of the easiest to understand and most straightforward ways to apply the math we learn in high school or in college or university. Things like algebra, geometry, trigonometry, even calculus are really well understood in the context of physics, and getting to apply them to a real-world problem makes that math a lot easier and a lot more real, something that we can really latch on to and understand better. Math had no meaning at all until I started integrating it with physics. Just trying to do calculations was boring, and I wasn't very good at it. But when I started doing physics, suddenly I cared about math, and I understood what my math teachers were trying to tell me. It works like that for physicists and mathematicians as well. The only reason we have calculus at all is that people were trying to understand how classical mechanics worked. What happened when planets orbited the sun? How did that work? What were the forces involved? And that kind of analysis is one of the things that led people like Isaac Newton to come up with calculus. So we really only have math because we have physics, and we only have physics because we have math. The two can't be separated out. I've been teaching introductory college physics for about a decade. And one of the things I know is that most people who take my class because they need it for their major. That may not be a very compelling reason, and it's one reason why a lot of people don't enjoy physics, is that they're being forced to do it. But on the other hand, you're probably being forced to do it. And if you are, then you might as well have a good time and get as much out of it as you possibly can. To impress your friends, is she serious? Actually, yeah, I am. A really interesting dichotomy between physics students and physics teachers. Physics students tend to come in and say, my professor wants me to learn how to push a block up a ramp, or how to connect 3 light bulbs in series. And physics teachers tend to say, I really don't care if my students know how to connect 3 light bulbs in series or push a block up a ramp. I want them to learn about how to think. And I think a lot of students don't realize that that's actually way more important than their final answer. The main thing you can learn from physics is one method of approaching problems. There's tons of problems physics can't solve. Physics will not tell you whether or not to break up with your significant other. But physics can tell you a lot about how to stop when you see something you don't know how to do, and to break it down into smaller pieces, to follow definite logical steps to help you move forward in a problem. And you'll find that that will be really applicable outside of your physics classroom, also in things like programming, in things like other science classes, in things like thinking about how to build a bookshelf. You'll need that kind of progression, even if you don't ever need to know all about pushing a block up a ramp. As an aside, this is why physics teachers often ask you to show your work. We're much less interested in what your final answer actually was. Did you make a mistake somewhere along the way? We're much more interested in what mistake you made along the way and what that taught you about what was going on. So we don't really care if you multiplied 2 times 3 and got 5, which is my most common math error. We care much more that you knew that you had a certain free body diagram, or that you knew that the answer you got at the end of the problem, where you said the Earth weighed 3 pounds, couldn't possibly make sense, and so something was wrong. We're much more interested in that kind of thing than in the final product. And if you think about physics in that way too, as a way to think about training your brain, sort of like a big Sudoku puzzle or something like that, instead of thinking of it as a treadmill to find certain answers your professor is looking for, you'll have a much better time understanding physics. I realize a physicist sitting in her office telling you not to be scared of physics for these 5 reasons is not the most compelling argument against being intimidated by physics. That's why, over the next few months, I'm going to create a series of videos that'll talk you through some of the basic concepts and common problems in physics. These aren't going to replace your physics class, and they're not even necessarily any better than any of the fabulous videos that already exist on YouTube. However, they are going to provide a slightly different perspective, the Deborah perspective, which I've been told is relatively helpful. Whether you're a current physics student trying to supplement your class, or a recent physics student studying for something like the MCAT, or maybe even your comprehensive exam, I hope you'll find something to learn, review, or maybe just enjoy. Until next time, physics isn't that scary, I promise.